everyone, and welcome back to your Artificial Intelligence course. Today I'll be talking about natural language processing, which is a main topic in AI. It's also one of the most prominent applications of artificial intelligence today. So natural language processing is an active and attractive field that's at the intersection of computer science, artificial intelligence, and computational linguistics, which is a field concerned actually with the interactions between computers and human languages. So what do we mean by interacting between human and computer languages? It means that we need to be able to have a computer system that can understand languages and also generate languages, and hence the communications between computers and human languages. Natural language processing involves language. Who says language says text. Text is actually at the basis of most of our activities online and offline. For example, we deal with a lot of data that is text today online. This includes emails, blogs, news, search results from Google, reviews, social medias, medical reports, course content, etc. Most of the text or the data out there today is actually in a text form. And it is estimated that we have about hundreds of thousands of petabytes of text available out there that is invaluable to shed some light on different concepts and topics. Why NLP? Because communicating with computers using natural language has always been a dream in AI since the very beginning of the field of artificial intelligence. Recall from the very first lecture in this course, we discussed the Turing test, which is one of the Alan Turing vision about how to deem or how to decide whether a machine or an intelligent system is really an intelligent system. A computer is deemed to have some intelligence if it can fool a human interrogator. In other words, we have a human interrogator on one side of the room, let's say. There is a wall between them. There is a human and an AI system on the other side. The human interrogator cannot see the human or the AI system, but it can communicate with those two through an interface. It has a keyboard and it can communicate through some text exchange. All right, so if the AI system can fool the human interrogator who cannot discover that actually it is a system, then this machine is deemed intelligence. So the intelligence is seen through Alan Turing vision as something that can be assessed through understanding the language, understanding the text, and responding and fooling the interrogator. We also have seen several applications of natural language processing. So remember Jeopardy, where humans played against IBM Watson in 2011. So this was one of the first time where actually natural language understanding and information retrieval were used by a machine and did beat the human champion players. We call also speech recognition through visual assistants like Siri from Apple, Echo from Amazon, Google Now, Cortana from Microsoft, in which these assistants, these smart assistants, help get things done. For example, send an email, check the weather, make an appointment, or etc., or even find a restaurant. So these kinds of applications leverage deep neural networks to handle speech recognition and natural language understanding. Another a remarkable application is the application of machine translation. We have discussed this a lot in the first lecture, in which the historical motivation in AI a long time back was to translate Russian to English. But the first system has actually seen a big failure because they were using kind of mechanical translation in which we used one-to-one correspondence. For example, this is a famous example from the literature that in which we tried to translate out of sight, out of mind, using a one-to-one correspondence that led us to invisible imbecile, which is brings a completely different meaning to what the intention of the sentence was. So actually, machine translation, as evoked, has gone through ups and downs, and today it has made significant progress through the use of what we call statistical machine translation that leverages the vast amount of text available out there from corporates, from the United Nations, etc. We have a lot of text that is translated by experts, and the goal of statistical machine translation is to use statistical techniques and probability to infer the right translation of text. So we have seen a lot of improvement in machine translation, and today many systems exist. Example, Google Translate that can translate over 100 languages online. So, and I put here back out of sight, out of mind. That comes back as hors de vue, hors de l'esprit, which is the right meaning of that sentence. Another important application of NLP is information extraction that actually aims to automatically extract information, structured information from unstructured text. So most of the time, text exists out there, either in companies or online, but this text is not structured, which means that if you want to get information out of it, you will need to do some information extraction to get the most important information out of the text. This system includes systems like Columbia News Blaster or News in Essence that can bring you the compact, reduced form of the news, but you get the essence of the news. Another famous applications is dialogue systems that actually exist through automated chatbots or online assistants. So we have here an example of discussion between a caller and a system. So who haven't experienced that, where you call some system to check your credit account or to check your account status or something like that. And when you have to discuss, chat first with the system before you get to an agent. And sometimes you don't need to get an agent altogether because the system was good enough to drive you to the right information or drive you crazy. Sentiment analysis is also called opinion mining and aims to extract subjective information or subjective opinion from a speaker, a reviewer, a writer. In terms of polarity of the sentiment and also or the intended emotion of that writer or reviewer. So most of the time, this kind of problems is cast as a classification or regression problem in machine learning that actually deals with data that is text. So natural language processing is truly an important topic in artificial intelligence since the beginning of the field, but it's also one of the hardest problems in AI. And the main reason of that is that human language is simply too complex for a machine. For example, language is by excellence ambiguous. Take this example. At last, a computer that understands you like your mother. So how can you interpret this sentence? You could think of it as the computer understands you in the same way that your mother understands you. You could also think about that as the computer understands you in the same way that it understands your mother. Or you could also think of it as the computer understands that you like your mother. So what is the real meaning of this sentence? Language is ambiguous, and in general, we like to have some more context or know the person to be able to understand the intention of the language. Another possible complexity of the language can come from what we call the anaphora, which is using pronouns instead of other entities referred earlier in the text. For example, he brought a brand new car and drove it home. The it here refers to the car. Okay, so use lots of these kinds of replacement when we talk or when we write. We also sometimes use indexical sentences in which we refer to or use to utterance places, situations such as places, time, etc. For example, I will be there or what did you do, which actually makes the sentence a little bit harder to understand and less straightforward. Metonymy is when we use noun phrases to stand for another one. For example, she learned how to play Mozart at a very young stage. So play Mozart is actually a metonymy. We don't play Mozart, we play Mozart's music. Human beings also love to use metaphors, which is the non-literal usage of words and sentences. For example, he is a walking dictionary or his room is a zoo. And we find a lot of this in many discourse and text, etc. So language is difficult. It's difficult for the machine to really understand all these kinds of variations and difficulties in the language.